So today we're happy to have Dr. Nastassja FISCHER, our research associate in the CFPR. So today she will talk about the neural basis of fairness perception in Singaporean preschoolers. So she is a member in our SGLeads project. Dr. FISCHER did her PhD in Federal University in Brazil. And she joined our lab almost 2 years ago. So we all know that in this quite challenging time, it's difficult to collect data in children, especially doing this kind of EEG studies. But nevertheless, she and the team managed to finish the job. And today we will see some of the findings from our previous EEG studies. So without further ado, I will give the floor to Dr. FISCHER. So yeah, let's get started. Thank you.
Okay, thank you, Prof. Yu. So hello, my name is Nastassja, and today I will present a talk entitled A Neuroscience Perspective on Fairness Perception in Singaporean Preschoolers. And this presentation is based on results with SGLeads data submitted recently to publication. So as a start, I will start this presentation by answering the question, what is fairness? How can we define such subjective concept? So technically speaking, we can define fairness as a moral value that helps us to judge whether resources are distributed equally or close to equal among peers. But however, this is a very basic definition, and on top of equality concerns, literature have shown that people, including children, can also apply other concepts such as equity to judge resource distribution among peers, reminding that equity refers to distributions valuations based on the deservedness rather than equality. And why is the development of fairness concerns is important? So according to evolutionary and developmental studies, the reinforcement of fairness-related social norms induces positive feelings and expectations of reciprocity during social interactions. It can also improve social cohesion, and it prevents someone from having an advantage in detriment of others, avoids one's exploitation for being overgenerous, and gives individuals the ability to track others' past behaviors and estimate the outcomes of future competitive or cooperative social interactions. And how do we evaluate fairness-related behaviors and fairness-related concerns? So to study fairness and resource allocation attitudes, we can use social economical games where people will enforce fairness values, but usually this enforcement comes at a personal cost. So that fairness in those games is pitted against self-interest and will vary in the very rules and payoff structures of the games will allow for investigation of the different subtypes of fairness. For instance, in one popular social game that is used to evaluate fairness is the ultimatum game, which is this one here, represented here, where two players must negotiate the partition of an amount of assets, for instance, money, and the proposer will be the one who is initially given control of the pot and is instructed to suggest a split to the responder, which is represented here, who has the option to accept or reject the offer. If the responder accepts the offer, the money is then divided as per the offer. But if the responder rejects the offer, neither player receives anything. So a purely self-interested rational responder would accept any offer above 0. And anticipating this, a self-interested rational proposer would propose the smallest possible positive amount. However, observational studies show that people do not follow those predictions. Rather, a standard result is that proposers usually split their assets in almost 50-50 way, and responders are sensitive to the proportion offered, rejecting an increased number of offers as the proportions of resources offered to them fall below around 30% from the total amount of resources. Therefore, the responder's rejection amounts to paying a cost of the offer size to punish the violation of fairness. Another game that is usually employed in studies is the Dictator Game, which is a variation of the ultimatum game. In this game, the responder, instead of having the power of accepting of rejecting the offer, the responder doesn't have any decision about the offer. So the responder can only accept the offer that is proposed to the dictator. Classical economical theories would predict that the most advantageous strategy for the proposer in this last game would be not to share anything with the receiver. However, results have shown that adult proposers typically give around 20 to 30% of their initial resources when playing the Dictator Game. Previous authors interpreted these results as an indicative that people are not only driven by self-interest motivations, but can also act driven by inequality aversion purposes. Previous studies have labeled this non-selfish behavior as strongly reciprocal, and they can be determined by internalized norms guiding the formation of a person's identity and influencing someone's worldview and actions. So the commitment to these social norms may lead people to act altruistically, even when it's not explicitly required. And it is known that those inequality aversion behaviors and fairness motivated behaviors are present since early infants, as early as 15 months old. However, the way children weigh how preferable is to follow social norms when playing these social games, and how to favor fairness-related principles may be dependent on several individual factors involving learned behaviors and brain network development. So, the implementation of social norms and consequently fairness-related values throughout someone's development depends, among other factors, on this person's brain development. Therefore, to study how someone perceives and implements moral values in their everyday decision, we can use knowledge coming from neuroscience. And that's when the developmental neuroscience field comes into play. So this knowledge that comes from neuroscience studies can inform us of the mechanisms that are underlying perception, attention, memory, language, and other cognitive processes at different points in the life cycle, and mechanisms observing developmental changes in those processes. So the developmental neuroscience field may integrate many disciplines such as experimental psychology, neuroscience, cognitive science, genetics, and social sciences. Its main goal is to understand the brain networks involved in processing social norms and decision-making. And for instance, it may intend to understand how the interplay between the sensory system, motor system, and social cognitive system affects the maturation of sensorial and motor systems and supports the development of social skills throughout time. To study brain function and its development throughout years, developmental studies may use several neuroscience methods. The choice of a method over another will depend on the research question and feasibility. And to give you a perspective, I bring here two examples of neuroscience methods that are widely used in literature. They are different from each other regarding costs, their physics, principles behind the methods, and the results provided. But all they are relevant to understand brain development. The first one listed here is in electroencephalography, as known as EEG, which measures electrical signals that comes from neuroactivity in the brain. EEG can acquire neuroactivity within milliseconds resolution, but it lacks a spatial resolution, which means that we cannot precise for sure the specific brain area where the signal is coming from, but instead we can only give broad estimates of it, but we can have a very good time resolution. The second one I'm bringing here is the functional magnetic resonance imaging, that is known as fMRI, that measures changes in cerebral blood oxygen level and is resultant from neuroactivity in the brain. fMRI recording, on the other hand, does not have the same temporal precision as a EEG acquisition, which means that the neuroactivity is acquired with some lag, with some time lag, but it has an excellent spatial resolution, which means that you can estimate exactly from where the neuroactivity is coming from. Oh, sorry. So by using neuroscience techniques, we can explore with minimal interference of subject expectation the brain contribution for the expression of morally guided behaviors across different developmental stages. And we can unveil neural networks involved in affective and cognitive processes and automatic brain mechanisms reflecting internalization of moral standards. So with this knowledge, new educational approaches aiming the improvement of children's social abilities may be based on typical benchmarks of moral skills and can be tailored to meet a child's brain development. So in our study, we choose to use the EEG to estimate brain processes while children were engaged in the Dictator Game that I explained earlier. In a typical EEG session, the participant, in this case the child, sits on a chair and the experimenter fits an elastic cap in their heads that seems like a swimming cap. This elastic cap may have some holes that are here, that you can see here in white, where we attach sensors that will acquire the neuroactivity coming from the brain, and this neuroactivity will dissipate through the head tissues until it reaches the scalp and until it's recorded by the sensor that is represented here. The signal that comes out from the EEG device do not tell us much, so it looks like this. And each line of these is one sensor. And we can only tell something about brain activity after we analyze it when the session is finished. So we can analyze the EEG signal in several ways. In our case, for the Dictator Game, we analyze the EEG data by using the event-related technique to acquire event-related potentials that is as known as ERPs. So an ERP is measured by having a raw EEG record that is marked by the delivery of repeated stimuli events to the subject. So these stimuli, or what we call event of interest, can be, for instance, a sound tone X that is played several times for some minutes. And then after the participant finished hearing the sound, the EEG recording is split in time intervals that may last as long as the experimenter wants. So this division will take as reference the onset of the stimuli. So when you have this EEG recording is split, you can average the times where same stimuli were presented to the participants, and then from this average you can find the event-related potentials. So these event-related potentials, they can have several names that will depend on the task that they are related for, but it will also depend of their direction. So if it's a positive deflection, a positive wave deflection, or a negative wave deflection, and it also depends when it happened. So for example, here, when you see P1, it means that this is a positive wave that happened around 100 milliseconds after our stimulus. So just to give you a perspective, one event-related potential very common is the P300. So the P300 is an event-related potential that is higher when someone is paying attention to stimulus that it's not common. It's an infrequent stimulus. So you can have this local peak amplitude here for the infrequent stimulus compared to the frequent one. So usually people, they relate the P300 for attentional processing, for example. Another example is the late positive potential, or as known as LPP. This late positive potential is sensitive to emotional stimuli, either pleasant or unpleasant. So as you may see here in this picture, when the person sees something, a stimuli that is emotional relevant, so for example, a family's picture, they can have a higher late positive potential wave compared to when they see a neutral stimulus. In this study, we investigated preschoolers. But why did we choose to investigate preschoolers? Well, previous research has already shown that during the years before formal schooling, the brain size and its structures, as well cognitive abilities, they undergo in rapid development. And in fact, it is known that in the first 2 years of life, a child's brain has already achieved around 80% of its adult weight. And by 5 years old, brain size is approximately 90% of adult size. So therefore, during these preschool years, it's a time when the development of the brain is most susceptible to environmental influences, and it's when it occurs a lot of important developmental milestones. Also, additional studies have shown that the way children develop during early childhood has long-lasting influence on their life chances in adulthood, and there are great individual differences in cognitive development among preschool children due to various social and family factors such as socioeconomic status, parenting styles, and learning environments. So as there is a relative paucity of studies investigating how preschoolers evaluate and react to assets distribution when they are the recipients of those distributions. In our study, we intended to explore how neuroactivity elicited by different resource allocation scenarios that could be equal or unequal divisions of resources, mediates fairness appraisal indexed by preschoolers' emotional responses. As previously remarked, to study how children evaluated equal and unequal division of resources, we used the Dictator Game with children being in the responder role. So it means that they were only able to watch the offers made by the proposer. And we also explored the relationship of children's prosocial and fear of mind skills and their brain responses to fairness evaluation during the Dictator Game. To achieve this goal, we used participants from 3 to 6 years old, randomly selected from the core SGLeads panel survey that is led by Professor Young. And this study was conducted along 2018 and 2019 by the Center for Family and Population Research at the National University of Singapore. In this survey, it was collected data from a nationally representative sample of 5,019 preschool children that were aged from 0 to 6 years old at the time of the interview. From this SGLeads main survey sample, we recruited children to participate in our sub-project called Improving Children's Social Skills. And this project is an intervention project that aims to train children's mind to build social emotional skills, such as cooperation, empathy, self-control, and to identify neurocorrelates of social cognition and decision-making in children. So in this project, I worked together with Professor Rohong Jung Yu and Dr. Elizabeth King and other voluntary undergraduate research assistants. This project also received valuable contributions from former team members that are here, that is Ms. Nao Hashing and Mr. Changrong Wang. So to identify the neurocorrelates of social cognition and decision-making and its relationship with children's social skills, we use this Dictator Game task, and the children in the recipient role, the children could see different resource divisions, and after seeing those different resource divisions, we asked them to answer us how did they felt, how did they feel about the offer. Their answers could be very sad, just okay, happy, or very happy. We told them that they would play the game with, they would see offers, that were assigned by other children that played the game with us earlier, but actually the offers were decided by a computer script that were showing 3 types of offer divisions: a fair or equal offer division, where the child would get equal or close to equal amount of candies as the proposer; a disadvantageous unequal offer, where the child would get less candies than the proposer; or an advantageous unequal offer, where the child would get more candies than the proposer. So after the child saw all the offers, and after we had the brain responses, we have to clean the data before analyzing the data. So this step we call pre-processing, and during pre-processing we employ several steps that will clean the data. So the data after we record, it will look like this. So the raw EEG signal is pretty noisy, and you cannot tell much about it. But then after employing all those computational analysis and computational steps that are represented here, we have the cleaned EEG signal that should look like this after cleaning. So this entire process, it's somewhat time consuming, because sometimes you have to have manual rejection and inspect all the signal all over to have this cleaned result. And sometimes if the acquisition is not so good, which means that if the child moves a lot, or if the child just take out one of the sensors because they want, or they want to play. So we have a very noisy signal that even applying all the pre-processing steps, we are not able to clean it enough to go further in the analysis. So especially with children, it's quite hard to acquire a sample, because we have to drop out some participants during this process. But when we have the clean EEG signal, we then do the ERP component analysis, and then by averaging the different conditions, after this ERP component analysis, we do the statistical analysis. In our case, as we are dealing with high-dimensional data, we employed a statistical plan that is recommended in our case. So the statistical analysis that we choose to employ is a mass univariate analysis that has as a first step the goal to localize where the brain activity is different across the 3 different conditions, so we can know where which sensors we have main statistical effects. And later, when we know where we can observe the main effects, we did pairwise comparisons across time to identify which conditions are different from each other, and also to identify which ERPs are involved processing each type of offer condition. And on top of those measurements, we also wanted to relate the neural processing with the behavioral measurements. So we used the false belief and appearance reality tasks that were used as baseline measurements of the intervention studies, and they are aiming to measure theory of mind skills and perspective taking skills. And also, we also use the prosocial scale of the strength and difficulty questionnaire that measure prosocial skills and empathy-related skills, and that was used in the SGLeads main survey in the first wave. So the behavioral analysis and brain behavioral correlations were composed by Spearman correlation analysis with the ERP components, and also comparisons of the emotional responses during the Dictator Game task. And also we explored the relationship between the emotional responses and the ERPs during the Dictator Game task. So as results, we could verify that children felt less happy with disadvantageous offers when compared to the advantageous offers and fair offers. There were no differences when comparing fair and advantageous offers. And this would fit with the inequality aversion theory, where we could see that disadvantageous inequality has lower emotional evaluation than advantageous offers, probably because of the negative emotions triggered by the inequality plus receivers' perceived loss. And the no differences in fair versus advantageous offers could be due to the fact that the fair offers could be more as rewarding as the advantageous offers because of their explicit moral relevance, which means that the fact that fair offers are socially valued, this could add emotional relevance. So this would be something that we could imagine by looking just at the behavioral results of the emotional responses to the offers. However, this was not what our EEG results showed, especially when it comes to the comparison between the fair versus advantageous offers. So when we compared the EEG responses of those 2 offers, we saw that we have this late positive potential ERP higher for advantageous offers compared to the fair offers. This ERP is usually higher for affective charged stimuli, and this ERP may encode that children were evaluating advantageous offers as more emotionally relevant than the fair offers. This was later supported by our results, showing that a positive association between emotional ratings to the offers within and the LPP ERP they were related to higher emotional reactions. So it means that higher the LPP responses to the offer were, higher were the children's emotional ratings for the responses, for the offers, sorry. Afterwards, the correlations between this late positive potential with behavior showed that higher the LPP amplitudes after the advantageous offers relative to fair offers, or more negative LPP difference scores between the offers were. Higher scores in the false belief content task were as well. So we interpreted this result by previous literature showing that there is a brain area called prefrontal cortex that is crucial for emotional processing and also for implementation of social norms, that is previously shown that is underdeveloped in children, which means that probably children may not implement completely the social norms that they learn in the environment because of insufficient activity in this brain area that do not regulate their emotional responses when they are seeing an offer and evaluating a fairness scenario. So additional results that our analysis found is that early ERPs, known as P100, N170, and N100, that are usually related to visual and sensorial processing of relevant social information. So, for example, facial perception. They were also related to fairness perception. So, on top of this, those early ERPs, they were also related to the performance, to the false belief content task, and also to the children's prosocial abilities. So our discussion about it is that the involvement of those early ERPs may be due to an integration of the visual cortex, that is a brain area responsible for visual processing. So every time you see something, that you have an activation of this brain area. But the integration between this visual area with amygdala, which is a brain area involved in automatic emotional responses. So probably the integration between these both areas may increase the processing of socially relevant stimuli, and this increased processing is indexed by increased amplitude of those early ERPs. Also, we could also find that individual differences in prosocial traits and perspective-taking abilities can also influence sensorial processing of social relevant scenario. So in summary, children's explicit attitudes regarding fair and unequal offers are similar to the ones exhibited by adults. So in the way that disadvantageous unequal offers were considered less pleasant than fair and advantageous unequal offers, but they are different when it comes to the evaluation of advantageous offers. So we found that in very young ages, children's brain may prioritize the rewarding value of earning assets instead of the potential rewarding value of following a social norm and being fair, especially when they are involved in the resource allocation transaction. So it may explain their apparently dubious behavior regarding fairness norms when comparing to their performance in third-party versus first and second-party resource allocation tasks. And also it may explain the young children's developmental delay in acquiring the advantageous inequality aversion behaviors compared to the disadvantageous inequality aversion. And to end with this presentation, we also could we also could find that early brain responses related to fast sensorial processes are also involved in fairness perception. So this is not just something sensorial, but it can also be something social relevant, the involvement of those early brain processes. So this fits with a dual process theory model for fairness perception that was previously developed for adults, but it seems that it's also present for children. But the difference from adults to children is that children may take more into account their own self-interest other than social norms when evaluating assets distribution, and when there is not an external factor in place, such as peer evaluation or a punishment role. So to wrap up, those are the references I use throughout the presentation. Feel free to ask me any of those if you are interested. And also, I would like to thank you for your time and for your attention. And feel free to email me or ask me anything you would like to. Okay, thank you.
Okay, thank you very much. Excellent talk. So anyone have any questions? So anyone have questions can use the chat box and just send message out there. Okay. B, we have question. Wait. Okay. I unmute.
Okay, so I see a question from BB's.
Yeah.
Yes. So actually, we didn't have enough sample size to divide the sample between female and male participants. So we could not investigate if there were any gender differences in our study, but this would be a very interesting question to investigate indeed.
I think I'm not the co-host, so I don't have the function to unmute anyone.
Oh, I see. Probably you should.
Yeah.
Yeah. So this is another question. So in our case, we have a hi, Professor Young. So in our case, we also could investigate the age differences, but again, our sample size limitation prevented us to investigate those differences. So yeah, but this would be also a very meaningful question to ask, because we have evidence that according to age, fairness-related behaviors, they change throughout age, especially the advantageous inequality aversion. It changes across development. So this would be something very meaningful to look at. Okay, so BB Young again. How do you see the progress in children's assessment of fairness with age? So previous studies, they evaluated how children divide their assets and also the rejection rates they had in ultimate thinking. So if the child rejects an offer very often, so this would imply that the child has like inequality aversion behavior. And what is found in literature that older the child is, they have more those advantageous inequality behavior. So they reject offers that are too advantageous for them. And this is interesting because advantageous offers, they are valuable to the recipient, but even though older children, they reject them, which implies that they are following the social norms and showing to their peers that they are a reliable colleague to trust. Yeah. Okay, so Thong Yok Lin, thank you for the talk. Thank you. And what would be the implications for early childhood educators? So for education, and this would be very relevant because this would say for the educators how a child would be supposed to behave depending on their age. And also we could identify if a child has any behavioral problems. So for example, for conduct disorders, when the child fail to comply to social norms and has social problems in interacting with others, those the understanding of how they understand social norms and how their brain process social norms can help us to aid the child and to improve therapeutical interventions to assist the child to acquire the proper social understanding. Hi, Prof. Young again. So, when I understand that you asked when children start to become sensitive to unequal distribution. So when it comes to the disadvantageous unequal distribution, infants are already sensitive. So you can see 15-month-old infants being sensitive to disadvantageous unequal distributions. But when it comes to advantageous unequal distributions, the starting age is around 8 years old. But this starting age, it depends also on culture. So there are some culture comparisons showing that individualistic cultures, the children, they start to have advantageous inequality aversion earlier than collectivist cultures. There is this differences. Yeah, there are those differences. So sorry, does it answer your question?
Yes, thank you.
Okay. So BB Yang, do you foresee a difference in children's assessment of fairness depending on their background, children from high income compared of those of low income background? Yeah, we would expect those differences, and this is one of my hypotheses. But sorry to give you this answer again, but we don't have enough sample size for it. So, and especially because of 2020 events. So we are not able to collect more children to investigate about those group differences. But this is my intention now from now on. So now that we are resuming our research activities, I hope I can collect more data and then have enough sample size to investigate those group differences.
Okay, good. Jing Li has a question. Go ahead.
Hello. Thank you for your talk.
Thank you.
Actually, I have two questions. The first one is that I'm just because I'm not unfamiliar with this kind of game theory. So I'm just wondering that there is general results across the culture and the country that adults have negative feelings toward the unequal treatments both for the advantages and the disadvantages. I'm just wondering, there is general results across the culture and the country. That is my first question. And the second question is that actually I'm from South Korea. So in my country, when we measure the children's emotional responses, we usually use a different scale, because I learned that in Western culture, mouth expression is very important for the emotional expression, but in Asian culture, children usually generally focused on their eye expression, like for when they express or observe, like smile or angry, like that. So so that is my second question about the measurements, like the scale, to express their feelings, like angry or happy, like this. So I'm just wondering that you have your opinions about this scale. Yeah, that's all.
Okay, so let me just remind me about your first question. It was about cultural differences in adults, right? In evaluating inequality, right?
Mm-hmm.
Yes. So yeah, you were right. Like for adults, advantages unequal and disadvantages unequal. Adults, they evaluate those as a bad outcome, probably because of social norms. And even Prof. Yu has a study showing that you can have this brain activation in areas that process conflict, and also just correct me if I'm wrong, Prof. Yu, but in areas that process conflict with in a social situation where you have negative conflict. So it seems that inequality for adults, it is perceived negative, no matter the direction of this inequality, even if they are earning more assets than their peers. This is because the theory behind this is because when you accept having an advantage over others, it means that you're probably potentially disregarding others' perspectives. So you're potentially a bad peer to interact with, and then this may potentially also leads to social exclusion. So the adherence to social norms, evolutionary speaking, is advantageous, because then it makes you feel a part of a social group, and then you can have advantage of being a part of a social group. But for children, the interesting thing is that because their brain development is still ongoing, they do not have this type of computation. So they have the automatic emotional responses winning, let's say like this, over the way of complying to a social norm. So the fact that they earn more assets, it's more rewarding than following a social norm. They don't have an emotional regulation, because to follow social norm, you have to develop higher cognitive processes. So they don't have this emotional regulation to suppress this automatic emotional response when earning more candies, for example. So that's why they adopt this emotional, and this emotional process is overweighing their implementation of social norms, and they are more prone to like more, let's say like this, the situation where they have an advantage over others. Even if when you ask them if it's nice to have more candies than their colleagues, they will say no, it's not nice. Even if you ask, when you ask them, they will say to you, no, it's not nice, but it's not what their brain activity is telling us. And another question about the facial scales. So I understand this may be something important to see. Our choice about choosing the facial scale, the emotional scale with the facial and also the mouth. It's because it resembles the emojis that are quite well used in cell phones and also in text messages. And also it's easier for children to press because they had to press a button to assign their emotional responses. So if the stimulus would be to assign the responses would be too complex, probably this would add a variability to our task. So we just decided to have a stimulus to them to refer how to assign the emotional responses and then pressing the button when having the emotional responses. It's just like a design issue because we have to have those events very well marked to be able afterwards to split the EEG data regarding that events. We cannot leave them free to answer whenever they want, or we can leave them free to answer whenever they want, but we have to know where things happened, and this has to have time precision. So we have to choose the stimulus accordingly. Yeah.
Okay, I think G also have a question.
Yeah. Okay. How similar or different are your findings about Singapore findings when compared with existing literature from other countries? So this is the good part. We don't have so for this test and for children being the responder, we don't have data from other countries. What other studies usually do is to place the children as a proposer. So we have many studies show about what are the neural responses when the child has to choose between how many assets they want to give to another, but there are none studies investigating what are the child's reaction when they receive the offer. So this is the new information we are adding in the literature. So we don't have other studies to compare for now.
Okay, any other questions? I think we still have time for one more question. Okay, if no more questions, I think we have very, okay, great presentation. Yeah, that's a very good question. I want to ask, but I probably not. Give me a hard time. Yeah, nice. Go ahead.
Thank you, Prof. Yan. How do we improve the design next? Okay, that's a good question. I would say like the thing that I would think is to improve the sample size to be able to investigate for groups comparisons like low SES versus high SES, age differences, gender differences. But above of it, I would ask the help of Prof. Because then we have to look further and then think about next what to investigate next. Yeah, if Prof. has something to add, I would be glad to have.
Yeah, I think there are quite many kind of follow-up studies we can do. For example, I mean, right now participants, they are basically just passively evaluate the outcomes. But I mean, in economic games, we can allow them to actually make some decisions. For example, reject the offer if it's unfair, or like this is second party. We can also do the third party punishment. For example, when the observed A gives unfair offer to B, I mean, even they are not involved, can they still like punish the unfair proposal? So things like that. There are quite many kind of topics we can further study. and I think it's a very interesting research area. So I think the difficulty is definitely not so easy to do this kind of EEG studies and invite children to our study site. I think when the COVID-19 is over, so in the future we can actually do more.
Yeah, for sure. Yeah.
Yes, yeah. Okay, great. I think it's 1 p.m. now, so we have very good timing. So thank you everyone. Thank you, Nastassja, for the excellent talk. So I think we finish here. Yeah, great. Thank you.
Thank you. Have a good day. Bye.
Bye, you too.